Princess has already given me an answer, and that's about where time is. So we're going to get started on this question. All right, first thing I'm going to note is I want to get rid of this minus CD. So minus CD must go over, C over D must go over to the other side. So I'm going to get F plus C over D is equal to MV squared over GR. Now, what I'm going to notice next is that this D in the denominator is going to give me a real problem when we are looking to move things around. So what I'm going to do is I'm going to change this part over here into one whole fraction. So I'm going to find this part an LCD of D. That's what I'm going to do. So I know that if I want to put this over D, I'm going to have to multiply the top by D as well. So on this side, I'm going to get FD plus C over D is equal to MV squared over GR. Now, I know that the G is in the bottom, and I want it out of the bottom, so I'm going to multiply both sides by GR times by GR on both sides. Those two will cancel. So I'm going to end up with GR multiplied by FD plus C over D is equal to MV squared. Now, the MV squared part is not a problem. It's not a problem for me at all. The thing that I want is G on its own. So I'm going to get rid of everything else. So I'm going to divide this whole side by R times FD plus C over D. And what I do on this side, I'm going to do on this side as well. So I'm going to multiply the side by R times FD plus C over D. And so that will cancel with that. This will cancel with that. Therefore, G is equal to MV squared over, if I want to multiply fractions, I'm going to take that thing on the outside and I'm going to multiply it with the numerator. So I'm going to get MV squared over RFD plus RC all over D. This looks ugly, so I'm going to change it around a little bit. G is equal to MV squared divided by RFD plus RC over D. And whenever I see a division sign, I'm going to tip and times. I'm going to KFC tip and times, depending on how you guys say it. Therefore, G is equal to MV squared times D over RFD times RC. All right. I know, I know, Abu, but we must always take it to the max. We must take it to the very top. I'm going to continue up here, guys. Therefore, G must equal, I'm going to, remember this is over 1. I'm going to multiply the top with the top, the bottom with the bottom, right? So I'm going to get G is equal to DMV squared over RFD plus RC. That's the final answer. And it doesn't look nice. It doesn't. But what I've done is I've taken everything we've just learned about mathematics and I've used that to manipulate the answer that we see. I've used addition of fractions. I have used division of fractions as well. And I've used multiplication of fractions. Ooh, it's a lot. It's a lot. But we've got to get used to all of these, guys. And we must get used to having ugly answers. Unfortunately, that's just the way the world works. All right. Good evening, everybody. I hope everybody is doing well. I'm just going to double check with you guys quickly before we continue. Today, we're going to be talking about exponential equations. That's today's lesson. On Wednesday, we are going to be talking about rational exponents or rational exponential equations, rational exponents. And then because you guys are going on holiday from Wednesday on, MathsLive is still going to have lessons. So we have lessons in the holidays. We have holiday lessons. Now, during the holidays, I'm going to be doing trigonometry. So I'm just going to ask you guys quickly before we continue. Just give me a yes or a no in the chat. Have you guys started trigonometry at your school already? Okay, I'm getting 2 no's, 3 yeses so far. Okay, another no. All right. Nonka says no. Okay, Abu started but stopped to go back, which is perfectly fine. All right, so over the holiday, I'm going to start trigonometry. And the reason I want to get it started is because that's exactly what your teachers are going to be doing. All right, when you come back from holiday, from the term 1 holiday, term 2, according to the grade 10 annual teaching plan, what comes next is trigonometry. So I want to give us a little bit of a head start. For those of you who've already started it, it will be like a recap. And for those of you who have not started it, that's going to be like you're gonna be ahead of everybody else. Yes, Narisha, absolutely. You'll be like, actually, ma'am, I already know the answer. Thank you. Please and thank you, ma'am. You're gonna be like, oh, how boring. I already know how to do these things. Like, how could they? Okay, so how are we feeling about that? Yes, thumbs up. Are we feeling okay about coming to lessons in the holiday for trig? Yes, just to get started on trigonometry, I'm thinking we're going to like really pump, guys. Trig is, especially when you get it, it's the best thing. It's so amazing and it's so nice in grade 10. So I'm going to give you guys a head start and we're just going to jump straight into doing it really, really well. Okay. We're going to get into it really, really well so that you guys can understand it. All right. Beautiful stuff. All right. Without further ado, what we're going to do now is we're going to get, oh my goodness, Krulani is already done. So Krulani is going to be doing revision. Okay, so here's what's going to happen, Krulani. You're going to do trigonometry with us over the holidays. And then when we come back from the holidays, everybody's going to do analytical geometry. We're going to do analytical geometry. Your teachers are going to do analytical geometry. So you're going to be just in line with what we're doing all together. Okay, so you'll be right on par with what's happening at school. Okay, so I'm hoping to see you guys then. And I know you can all make it because you have no other lessons. I know this for a fact. All right, let's get started on today's lesson. Okay, so let's go back to exponential equations quickly, because, or exponential exponents just in general, right? Now, if I say to you guys, I've got 2 to the power of x plus 1 times 8, right? I know that I cannot compare exponents unless I have what? No worries, Omi, let me change that for you. Oh, not factors, my darling, not factors. What are we looking for? Yes, that's it, princess. Good. We want the same base. We want like bases, correct. So the only way we're going to be able to compare exponents is if we have like bases. So what we're then going to do is we're going to prime factorize 8. Absolutely, Abu. So we're going to end up with 2 to the power of x plus 1 times 2 to the power of 3. And only then, when we have the same base, when we have like bases, can we then compare exponents. Now, this idea also works when we're talking about exponential equations. Now, if we look at this equation that ma'am has given you guys over here, I've got 2 to the power of x, and on this side, I've got 32. Now, I don't have the same base on each side, but I know that I can rewrite 32 as, yes, Rulani, absolutely, as 2 to the power of 5. So I can go 2 to the power of x is equal to 2 to the power of 5. And now the nice thing about exponential equations is as soon as my bases are equal to each other, I can drop them and I can make my equations equal to each other. Therefore, x is equal to 5. Thumbs up, everybody's gotten this one. Nothing difficult here. I didn't revolutionize maths. I say that all the time, but it's because I'm not. We've all learned these things since grade 8. We know how to do them. They're quite nice and easy. All right, so we're going to jump straight into today's exercise. I'm going to give you guys 4 sums. Okay, there are our 4 sums for us to practice with. I want you guys to use what we know about exponentials or exponents, and I want you guys to answer these 4 questions, and then you can pop your favorite emoji in the chat. My emoji of the day is this one, because I've got flu, I've got nasal congestion, I've got bronchitis, I've got everything all together. And Narisha, remember, favorite emoji in the chat, so I'm not feeling so lekker. All right, favorite emoji. Otherwise, you're going to spoil it for everybody. Everybody's just going to type your answers. Thank you, my darling. I will try. I've been given 2 days off work, which means I haven't been to school today, and I'm not going to school tomorrow, and it breaks my heart because I really love school and I don't want to break. I want to go back to school, and my doctor is very mad at me for wanting to go back. I don't know. I'm addicted. I'm addicted to my job, guys. It's because I love you guys so much. I love teaching. That's why I want to go back. Sure. Freedom is already done. My word. Some of you guys are like powerhouses. Damn. All right. Let's wait for everybody else to catch up, Fulani. Omi, are you feeling the same, or are you just copying my emoji? Oh, thank you. Just to make me feel better. Thank you. Narisha's feeling very Japanese today. I like it. All right, I think we're all pretty much done with these questions. So let's have a look at some of these answers. And how did I just lose my status? Oh, there it is. Okay. All right. So this one is quite easy. I've already given you guys the same basis for number 1. So we're just going to drop our bases and x is equal to 2. That's easy enough. All right. Over here, I know that I can change 27 to a product of its primes. So I can pop. That's going to give me 3 to the power of 3. And therefore, those two will cancel. Absolutely, Filani, x is equal to 3. Good. Now, on this side, I know that I can change 9 to 3 squared, but I'm going to get 3 to the power of x is equal to 3 squared. But 9 was already to the power of 2. So this becomes 3 squared all squared. I've got a bracket and an exponent. Those two things will multiply each other. 3 to the power of x is equal to 3 to the power of 4. Now that I have the same base everywhere, I can cancel. Therefore, x is equal to 4 for number 3. 1 mark, 1 mark. In this last one over here, the problem is actually on this side. Okay, so on this side, I'm going to get 2 squared to the power of x is equal to 2 to the power of 8. I see a bracket and an exponent. I'm going to multiply those two things. Therefore, I'm going to get 2 to the power of 2x is equal to 2 to the power of 8. We can drop our exponents. That tells me that 2x is equal to 8. Divide both sides by 2. Therefore, x is equal to 4. All right. I want us to first pop the answer we have. I mean, the number we have. How much did we get out of 4? Sorry. Our total out of 4 in the chat, please. Let me know if you got 4 out of 4, 3 out of 4, 1 out of 4. Tell me. All right. Princess, do we see, if we did get 3 out of 4, do we know where we kind of sort of didn't get it? I hope we can tell. Yeah. Okay, excellent. I knew everybody was going to get these. These are quite easy. Now, the reason why I want us to do these kinds of questions is that because you guys are in grade 10, and a lot of the processes that ma'am has used to get to the answers here are already grade 8 and grade 9 work. We don't actually have to go through every single step. Okay, so what I mean by this is, in question 1, that's easy. In question 2, they're only going to give you 1 mark for this question, even if you did do 2 steps. Because in grade 10, we can automatically see that 27 is equal to 3 cubed. So if you went straight from here to there, your teachers wouldn't mark you wrong, because this is actually a grade 8 concept. Okay, same with over here. If we skipped this part over here where it says 3 squared to the power of 2 and we went straight to 3 to the power of 4, you would only get 2 marks for this question. You wouldn't get all 3 marks. They wouldn't go 1, 2, 3. They would only give you those 2 marks. Because that extra step, that's a grade 9 concept. Okay, same with over here. We don't actually have to do this part over here. If you had gone straight from 4 to the power of x to there, if you had gone straight to there, and then if you had skipped this step and gone straight to there, they would have given you the marks. So this question over here is actually only worth 2 marks, 1 and 2. All right, so in grade 10, we are allowed to make logical leaps. Okay, you are allowed to make logical leaps. Okay, as long as you don't take huge logical leaps that don't make sense, you are allowed to do that. And that's why you look at some of those long questions that we did, especially those exponents the exponents ones, and you're like, ma'am, how many marks is this? And I'm like, it's only 3 marks. And some of you guys are like, ma'am, why? It's because a lot of those steps that we're taking in between are actually not grade 10 steps. They are either grade 8 steps or grade 9 steps. So we should be able to make those logical leaps without them costing us marks. Give me a thumbs up. Are we all okay with this idea? Yeah? Okay, remember guys, maths is about being lazy. Maths is about being lazy. So if there's an easier way for us to get to an answer, we're definitely going to take we're going to take the shortcut. All right. That being said, I'm going to give you a couple more questions to do. I want us to do questions 5, question 6. Oh, sorry, give me a second. I don't know what I'm doing now. Okay. Do questions 5, 6, 7, and 8. Okay. Give yourself some time to understand what the questions are actually asking. Okay. Okay. And again, I'm only going to give you guys 5 minutes because you guys are really good at this. So we should, at this point, already know what the answer to question 5 is without having to look at it. I'm going to remind you guys, anything to the power of something. Anything to the power of equals 1. Who remembers? Anything to the power of what? That's it. Oh, me. Beautiful. That's it. Anything to the power of 0. So we don't even have to go to that step where we write this equals that. We can just say x equals. Skip that part because we're already smart enough to get there, guys. We don't need that extra step in the middle. All right. If you have any questions on any of the questions, yes, if you have questions about any of the questions, please DM me and I'm happy to help. All right. Princess says, ma'am, the last two, they're not too bad, my darling. I'm going to show you why they're not so bad. I think we're just overthinking them a little bit. Remember, in this one over here, Princess, this is 2 times 5 to the power of x is equal to 50. That's 7. I think that 7 is misleading. Let me do this. This is the actual sum, just that part. All right, just the 2 times 5 to the power of x is equal to 50. Okay, think about how you would solve a normal equation. Oh, I'm sorry, it's not 2.5. Remember, Princess, in South Africa, for 2.5, we use 2 comma. We would use a comma instead of a point, right? The Americans use a point. We use a comma. One more minute, guys. All right, peeps, let's discuss answers. I have somebody saying exponents are not the one for me. And guys, if I'm being completely honest, even when I was in grade 10, exponents were not the one for me. I did not like them at all either. All right, so don't stress if exponents are difficult for you guys. They're difficult for most people, so don't stress it. All right, now I know that anything to the power of 0 is 1, so I could have easily written this as 4 to the power of x is equal to 4 to the power of 0. Therefore, x is equal to 0. Now, even if I had jumped straight from there to there, that would have been perfect. You would have gotten the mark. It's only a one mark question. It's not going to cost us anything. Now, in question 6, right, guys? In question 6, if I said to you guys that I've got 2 to the power of negative x, how would I change that thing to a positive exponent? What would I do here? Good, I would change it into over 1. I would change it to over 1. And then I would flip them. I would take this down and I would take this to the top. So I would end up with 1 over 2 to the power of positive x. Now, in this particular question, they've given us that part. So what we're going to do is we're going to take the 2 to the power of x and we're just going to flip it. And we're going to take it to the top. So that x, that 2 to the power of x, will then become 2 to the power of negative x. So this part will then become 2 to the power of negative x is equal to, I can then rewrite 8 as 2 to the power of 3. There we go. I've got the same base, so those two will cancel. And now I've got negative x is equal to 3. Therefore, x will equal, I can't have negative x, I want x. Therefore, x is equal to negative 3. All right, so we just need to know how to manipulate the mathematics a little bit and get it done. All right, so question 7, there are 2 ways for us to do this. If I said to you guys that I've got 2x is equal to 8, I know that in order to get rid of the 2 in front of x, I would divide both sides by 2. I would divide by 2, divide by 2. Therefore, x is equal to 4. I could do that, right? So now in this particular question that I've got over here, I've got a 2 in front of the thing that has x. So what I'm going to do is I'm going to divide both sides by 2. I'm going to divide both sides by 2. Then that and that will cancel. And I will then get 5 to the power of x is equal to 50 divided by 2 will give me 25. And therefore 5 to the power of x is equal to 5 squared. And therefore x is equal to 2. Another way you could do this is, instead of doing that, you could take your calculator and you can click 50 equals shift fact. And what's going to happen is you're going to get 2 to the power of 5 to the x is equal to, if you click shift fact on your calculator for 50, you're going to get 2 times 5 squared. And then I know that if I have 2 on both sides, the 2's will cancel. And then all I have left is 5 to the x is equal to 5 to the 2. Therefore, x is equal to 2. All right, so you can do that both of those ways. It won't make a difference. Right, now let's get to question 8. Because question 8, we're going to solve the exact same way we solved question 6. Right, if I have to take 4 and take it up to the top, first I can prime factorize 4. And I can make 4 into 2 squared. So I can have 1 over 2 squared all to the power of x is equal to 32 can be written as 2 to the power of 5. Now, if I take the 2 squared to the top, that then will give me 2 to the power of negative 2 all to the power of x is equal to 2 to the power of 5. I see a bracket and an exponent. I can multiply those two things in. So what I actually have is 2 to the power of negative 2x is equal to 2 to the power of 5. My 2's will cancel, my bases will cancel, and I will then have negative 2x is equal to 5. All right, and then in this particular question, I would divide by negative 2 on both sides. Negative 2. We mustn't be afraid of fractions in our answer, guys. Our fractions are exactly the same as any other answer. As long as we have fractions, as long as we've done the mathematics correct, we should get the correct answer. -5/2. Let's see, how did we do? We should get one mark there, 1 mark there, 1 mark here, and 1 mark there. How much did we get out of 4 for questions 5, 6, 7, and 8? How much did we get out of 4? Omi says 3. Omi, do we know which one we messed up? Did we see where we did it? I hope we haven't, just said, okay, good, my darling. I hope we're not just saying, yeah, we didn't quite get it. I see. The last one was very tricky. I'll give you that. It was quite tricky. But remember, guys, we must learn how to manipulate the math. Mathematics is just about manipulating numbers. We're just moving things around to get the answer that we want. All right. So in a way, mathematics is actually very, very creative. We need to get creative about the mathematics. All right. Can I give you guys 2 more questions? There's one and there's one. And then we're going to step it up a little bit. Let's do question 9 and question 10. I want you guys to note that because this is 1 over, we can use the exact same trick that we used with all the other 1 overs to get to the answer that we want. All right. And then for this last one over here, I'm just going to put a space in between that and the number 10. I want somebody to remind me. Narisha's always judging how I say things in math. I don't mean manipulate like manipulate, like not toxic behavior, manipulate. Not like that. Okay, because he says, so ma'am, for the last question, the negative dropped the 2. Vukosi, can you explain a little bit, can you explain that again in a different way, my darling, because I'm not sure what you're asking me. Oh, it didn't drop the 2. It is there. Unless you're talking about this last answer here. Here is the negative. It just became -5/2. Okay. Princess, they shouldn't. They shouldn't, because when one of the x's moves over to the other side, a negative should become a positive, or a positive should become a negative. So check again, Princess. Trulani is already done. Oh my goodness. Okay, I'm going to warn you guys, before we assume we're done with 10, make sure that you're doing the right things, hey? Make sure that you're doing all the right things, guys. Okay, double check, because there's a trick in number 10 that's going to get us. And we need to remember our laws of exponents as we go into that question, all right? All right, 2 more minutes, guys. 1 more minute. I think less than, actually. All right, peeps, let's have a look at these questions. All right, in question 9, I know I'm just going to get 3 to the power of x minus 2 is equal to, and we said we can take this 3 to the power of x and take it to the top, and that's going to give us 3 to the power of negative x, because I have positive x down here. So those two will cancel. I'm going to end up with x minus 2 is equal to negative x. I'm going to take anything with an x to one side, anything without an x to the other side. The negative x will go over and become positive, and the negative 2 will go over and become positive. So I'll end up with x plus x is equal to 2. Therefore, 2x is equal to 2, and that means that x is equal to 1. All right, and that's the answer we're looking for number 9. Now, in number 10, I know that I need the same base everywhere, and I've got a 4 there, and I've got an 8 there. So I need to write those two as a product of their prime bases. So this is going to be 2 to the power of 1 times 2 to the power of 2. All of that to the power of x minus 1 is equal to 2 to the power of 3, all to the power of negative x. Now, we've got to do a bit of distributing, grade 10s. So I've got a bracket and exponent that must distribute to both of those. And bracket and exponent that must distribute to that. So what I'm going to get is 2 to the power of 1 times 2 to the power of 2x minus 2 is equal to 2, and I'm writing 3. 2 to the power of negative 3x. Now, before I continue, I'm going to note on the side that I have like bases being multiplied. So I need to keep my base of 2, and I need to add my exponents. So now I've got 1 plus 2x minus 2. That's going to give me 2 to the power of 2x minus 1. And that is going to equal to 2 to the power of negative 3x. Now that I have the same base on both sides, cancel, cancel. So I should then get 2x minus 1 is equal to negative 3x. And then we must shift things around. Negative 3x will go over to that side. Negative 1 will go over to that side. I will then get 2x plus 3x is equal to 1. That tells me that 5x is equal to 1. Therefore, x is equal to 1 over 5. That's the answer we should get, 1 over 5. All right, how did we do out of 2? 1 for 9 and 1 for 10. Did we get both right, or did we only get 1 right? How did we do? Well done, Khulani. Omi also got 2. Vukosi, do we see where we went wrong? I knew this one was going to be a little bit tricky, especially with that 2 sitting on the outside. It was very important that we did that. All right. And remember, guys, if we do the same thing, if we try and do the same thing that we did up top here, where we divided both sides by 2, it wasn't going to work, guys. It was not going to work. And the reason why it wasn't going to work is because we can't divide this side by 2 and divide that side by 2. If I try and divide 8 by 2, I would get 4, yes. But this is not 8. This is 8 to the power of negative x. It's not the same as just 8. So I can't divide both sides by 2. All right, so be very, very careful with that. Okay, let's step it up a notch, as we always do. As we always do. Here's some difficult-ish questions over here. All right, these aren't numbers. These are actually, these aren't a number. It's not a numbering system. So this isn't number 4. The question over here actually says 4 times 25. Okay, so I want you guys to try this one, try that one, try that one, and try that one. Okay, pop your favorite emoji in the chat when you're ready to answer either of those. Now, number 3 is going to really kick our butts. So let's think outside the box. Let's think about outside the box for number 3. All right, take it away, guys. Pop your favorite emoji in the chat when you're ready. I'm going to tell you guys now, number 3 is meant to be difficult, so don't stress if you're struggling with it. I'm going to show you guys how it's done. If you think you have an answer for number 3, also DM me. I want to see where our thinking is. All right, I'm going to give you guys 1 more minute. You can also tell me if you're struggling. I know these are really difficult, except number 1. Number 1 is quite easy. All right, peeps, for the sake of time, we're going to go through these questions quickly. Okay, in the first question, this is quite easy. We can just divide by 4 on both sides. We can just divide by 4, divide by 4. Those two will both cancel. I'm going to end up with 25 to the power of x plus 3 is equal to 1. And I said that if anything, or Omi said, if anything is equal to 1, we can just write it as something to the power of 0. In this case, I'm going to choose 25. So I'm going to rewrite 1 as 25 to the power of 0, so that I have the same base on both sides. So those two can cancel. That means that x plus 3 is equal to 0. Therefore, x is equal to 3. Oh, -3. Let me not lie. X is equal to -3 on the side, which is quite nice and easy. All right. Okay, and somebody just said, I know the answer for number 3, but I just automatically knew. I can't give you marks for things that you automatically knew in your head. That's going to be difficult for us to prove. So we can't do that. All right, we need to write down an actual method. Okay, in this particular question, I know I can rewrite 0,5 as 1 over 2. 0,5 is the same as a half. So I've got a half to the power of x minus 1 is equal to a quarter to the power of x. Now that I have 1 over something, I can take both these sides and I can take the bottom and I can write it as 2 to the power of something else. I'm going to change this 4 over here to 2 squared. All right. So what I'm going to get on this side is I'm going to get 2 to the power of -1. All of that to the power of x minus 1 is equal to, I know that 1 over 2 squared can be written as 2 to the power of -2 all to the power of x. And then we're just going to distribute each of those in. So I'm then going to get 2 to the power of -x plus 1 is equal to 2 to the power of -2 times x is -2x. All right. So my bases can drop. I will then get -x plus 1 is equal to -2x. And then we just switch things around. -2x will go to the other side and +1 will go to the other side. So I will end up with -x plus 2x is equal to -1. And -x plus 2x is just x. Therefore, x is equal to -1. That's my final answer there. Now, just tell me in the chat, yes or no, did you manage to get an answer for question 3? Let me know in the chat, guys. Kulani says yes. I also know that Kulani may have cheated a little bit to get to the answer. How about the rest of you guys? Did we manage to get an answer for number 3, or did we get stuck somewhere? Narisha, what does yesn't mean? You need to explain to me, what does yesn't mean? I have no idea what yesn't means. Oh, okay. Omi's like, no, ma'am, not at all. Okay. So there are 2 different ways that we can solve for this question. Okay. First thing we can do is we can take 8 and we can write it as a product of its prime factors, and we can take 3 and write it as a product of its prime factors. Okay, so I can do this. I can write 8 as 2 cubed times 3 to the x is equal to 27 is 3 cubed times 2 to the x. Now, if we look at this from, oh, my dogs are being extra. If we look at this from what value of x would satisfy both sides of this equation, just give me 1 second, guys. Okay, so if we look at what value of x would satisfy both of these equations, what would x be equal to? X would need to equal what? What value of x would satisfy both of those sides? That's correct, Fulani. The answer would be 3. X would be equal to 3. But this is not really, I mean, yes, the answer is correct, but we didn't really use a mathematical method. So what I'm going to do, guys, is what I'm going to do here is I'm going to take everything with an x over to one side and anything without an x to the other side. So because these 2 things are multiplied to each other, I'm going to divide on this side by 2 to the power of x. And then I'm going to divide this side by 2 to the power of 3. Now, I must do both things on each side. I must also divide the side by 2 to the power of x. Those two will cancel, and those two will cancel. So what I end up with is 3 to the power of x is over 2 to the power of x is equal to 3 to the power of 3 over 2 to the power of 3. Now, I know, guys, if I say to you guys, I've got 4 over 3 all to the power of x. If I've got this, I can distribute that x to each of these. So what I'm going to do over here is I'm going to use this rule, but in reverse. I'm going to use this rule in reverse. So I'm going to take x out of both of these. So I'm going to end up with 3 over 2 all to the power of x is equal to, now they both have 3 as an exponent. That's going to give me 3 over 2 all to the power of 3. These two things are like bases. So I can drop my bases. Therefore, x is equal to 3. All right. So it is quite a tricky one. We can do it by inspection, but nobody's going to give you marks for doing it by inspection. We need to be able to see the mathematical steps that we've taken in order to get there. All right. So this one was quite challenging. I'll give you guys that. All right. I want us to look at this question over here, because I can guarantee you now it's not what we're thinking at all. We've only got 3 minutes of the lesson left. So if many people vote yes, I will do the question. But if some people vote no, then we can call it a night. Do you guys want to try the question, yes or no? Let me know. Narisha, I'm not sure what yesn't means. All right. I want you guys to follow with me. Omi says next time. Okay. I've got 2 yeses and 2 no's. Let's see. I need somebody to tie break this particular question. Oh, Vukosi says yes for homework. Guys, you've tied it again. I need one more person to vote, please, to let me know if we should try it or not. Okay, Narisha says no. Theo says okay. Vukosi says okay. The no's have it. Unfortunately, okay, we're not going to try this one. All right, but I will give you guys a hint before we try it again. Theo, you're confusing everybody. No, how have you voted? All right, I'm going to ask you guys, remember when we did exponents, when we were just looking at exponential expressions, when we had a plus or a minus in the middle, what did we have to do in order to solve for those exponents? When you had a plus or a minus in the middle, who remembers? What did we have to do? Anybody remember? Yes, Lulani, correct. We had to factorize and take out an HCF. But I'm going to stop it there for now. And we can continue again with these sums on Wednesday. All right. All right, peeps. I'm going to call it. Have a great evening, everybody.